But the second important thing that I wanted to talk about was the reduction formula and co-ratios. So in other words, what I'm saying, I'm not going to reteach it. I'm giving you what is important to know for the exam. You need to know the identities, how to convert a ratio into a triangle on the Cartesian plane, and you need to know your reduction formulas, how to use them, and your co-ratios. So let me just show you in the exam where one of those were applied. And guys, I promise you, this was really not a difficult trig section. You can expect more difficult than this. I promise you, this was not difficult. Look at these questions that we've done so far. It was really, if you knew these basics, you would have been able to apply it. Okay, so let me show you this one. So the whole aim is simply to get every I say pas, cas, and das. Positive, acute, and simple. So in other words, acute means less than 90. Positive means each angle must be less than must be more than 0. So positive angle. Acute means each one must be less than 90. And simple is sometimes I will have to use my double and compound angle ratios to simplify. So here we can see that cos of 325, there's different ways you could have applied this one. All you need to do is simplify it so that it's an acute angle. So using either, I prefer you guys stick with 180 plus or minus, 360 plus or minus, and only later on look at 270 plus or minus, or 90 degrees plus or minus. The reason why is because if you use 270 plus or minus, or if you use it from the beginning, you're going to need to use 270. But if you wait a little bit later, you'll see the 90 plus rather, which will be simpler to use. Okay, so 325, that is what? Okay, so this is cos of 360 degrees minus 35. Okay, notice I'm not saying it's 360 degrees minus 325. I am rewriting 325 in a different way. It's like telling you I am 40 years minus 9. I didn't change my age. I'm still 31. I don't say I'm 40 years minus 31. Okay, I'm just expressing my age in a different way, but it's still my age. So in the same way, this is still 325. I've just written it as so that it contains this expression, the 360. Okay, what about sine of 745? Good, you can use any multiple of 360. So so 360 times 2 is 720. So you could just say this is 720 plus 25. Now this is minus. You'll notice there's no multiply in between here. This is minus. Now cos, now if I'm working with negative angles, I'm in which quadrant? Forget about which quadrant this, well, okay, now let's use a plus or minus. What can this be? How can I get negative 205 using one? Good. Negative 180 minus 25, and then the last one. Sorry, this one is already in acute, so we'll just leave it for now until we see. I don't really know what to do now. Let's then I'll maybe change some angles so that they fit a bit better. So now we use our our Cartesian plane. So since we've just used 180 and 360s, I just need to include that. I don't need to use my 90s yet. I know this is my cast diagram. Cast diagram. So this cos of 360, there's 360 minus 35 is in which quadrant? Fourth quadrant. Cos is? So I need to keep the sign the same. So this becomes cos of 35. Sine of 720. 720 just means I went around once and I went around another time. So I'm here now, plus 25. I'm in which quadrant? So this is sine of 25. Okay, now this one, negative 180 is where? This can be positive or negative 180. So negative 180 means I went all the way there, and then negative 25. Am I going up or down? Up. I'm going anti-clockwise when I go negative. So I'm in which quadrant? I'm in the second. Which one is positive? So cos must be? What is it going to do with the... Is it already negative, so I just keep the negative? No, it means I must change the sign. Doesn't mean cos is negative, it means it changes the sign that's in front. So this negative must become positive. Cos of... And this one we said we're going to keep it cos of 55. What do you guys see so far? Can you see anything at this point? Yeah, there's something there. There's a cos of 25 sign. What did you say about it? They're similar. We should just speak a little bit louder. I'm slightly deaf. Okay.
How many marks does this count?
6. You already got 1, 2, 3.
For writing that. Can't we change cos 55?
Yes, we can. Into what?
35 plus 25, I think. I'm not
No.
sure.
Guys,
Oh,
don't...
to sine.
To sine.
Oh, goodness.
Because 55 plus what gives me 90? So let me take this away. The 55 I can rewrite as 90 minus 35. So cos can change into sine of 35. There's your 4th mark. Oh, I wonder if you guys see it.
What's that? Isn't it cos... Wait. Why don't you put it in order first? It's because it's wait.
Do you recognize, Busa, do you recognize it?
Isn't it the sine?
It's the sine. Same sign, different ratio. There's a cos sine, sine, or cos sine, cos sine. Okay? So if it's same sign, this is sine, and inside the angle, must it be a plus or minus? Plus. Same sign. Sine is same sign.
Yes.
So if this is a plus, and I know it's different, this is a plus, or no, let's try the same. I notice it's different ratios, so it must be sine. Different ratios, so it must be sine, because sine has different ratios. So I notice that the sine is a plus, so sine must have a plus because it's same sign. And now what's the two angles that must go in here? Okay, now it's important to start with the correct one, because sine must be sine starts with sine. So I must start with the angle inside sine. 25 plus 35. Now in this case it didn't make a difference, because it's a plus. 25 plus 35 is the same as 35 plus 25. But if it was a negative, I should have started with the sign, because then 25 minus 35 is different than 35 minus 25. You get it?
Yes.
So do you see, who of you would have gone to your formula sheet and looked at if your formula sheet can tell you what to do from here onwards? No, it's only in recognizing this is the... And so what is the inside here? So this is another mark. We're up to 4 marks now, 5 marks. 1, 2, 3, 4, 5 marks. So inside here I get
16. And then you change 60 to 3 over 2 square root of 2.
Yeah. So you get a mark for finding that the inside is 16. So actually, remember when I went through this, I said that first question didn't have compound? I lied. I forgot. It did. It did. So far, there's only one question on this whole paper in trig that didn't have compound angles. Nice. Okay, we've done most of it so far. Okay. You'll notice now that in these reduction formulas and co-ratios, usually we use pas. The next one is cas, changing everything into cos and sine. So let's look at, in this case, everything was cos and sine anyway. Let's look at another question on here. They ask us to prove, we've done almost all of it, but now they ask us to prove that this left-hand side is equal to the right-hand side. Okay, so what do you guys think we're going to do? Pas, cas, and das. Always. Okay, when we want trying to simplify or to prove an identity, that is really the basics. Is we really simply going to do pas, cas, and das. So pas, positive, acute, and simple. Okay, that will be the first step. Change everything into, so we're doing it on the left hand side. You'll see the right hand side cannot simplify any further. There's nothing you can do there. So we'll only be using the left hand side and simplifying it. What do you think we're going to do for that first one? Cos 2 theta. Stop picking at your... Okay, so let me just quickly show you. Okay, no, that's fine. Okay, 1 minus 2 sine squared theta plus sine squared theta, 1 minus sine theta. And here I can see the top simplifies because I've got 1 sine squared, but I'm subtracting. Guys, and if I see this once again, I'm going to flip. I mean, that's what we spent the whole first 3 months of the year trying to teach you, is that you cannot cancel over terms. Yeah, over an addition or positive. You can only cancel if you factorize the numerator and the denominator. That's the only time you can cancel. Or if in the numerator or the denominator only has 1 term, but we've got multiple terms. And guys, this, I tell you, it's scary to see how many people did that. You can't do that. I've got 2 sines being subtracted and 1 sine squared. So I'm left with 1 being subtracted. You get what I'm saying? Now look how easy this was. Any suggestions? What can we do beyond this? So far you got 1 point for replacing the cos 2 theta, and you got 1 point for simplifying the numerator. I think so. No, it's only 3 points. You didn't get this one. I'm in a fraction. What I would love to do in a fraction is cancel. But what did I just say?
You can't cancel
Unless I? Yeah? Say it?
I see.
No, say it.
Well, the top part is
Yeah.
basically exactly the same as the one, just that it doesn't have a square, so you get rid of bottom side.
No. What did I just say? You cannot cancel unless you factorize. So we must factorize. What factorizing do you see here? No, because it's not common in the first term. Guys, well, let me ask you this. Would you be able to simplify this for me?
Yes.
Now, what's the difference between these two?
Isn't it gonna be?
That's it. This is just 1 minus something squared over 1 minus something. The something just happens to be a sine theta.
Isn't it gonna be 1 minus sine theta, and then the other bracket is gonna be 1 plus sine theta, and then you can cancel.
There were so many questions like these in the course. Okay, and then now I can cancel. I can cancel this and that, and I'm left with and that's what we no? Sorry, that's a plus. So it's these two that cancel, so I'm left with 1 minus. Sorry, I forgot I wrote the sign wrong there. Okay, so it was only 3 points. Not a lot. Often what they would do is they would ask you this question, then they would ask you to for which values will this identity be undefined? What would we do then? For which values will this identity be undefined? Which values of theta? When is something undefined?
When the calculator says math,
So how does the calculator know this is undefined?
because the denominator is 0.
Nice. Okay, so for when is it undefined? When 1 plus sine theta is equal to 0.
So sine theta can
So when sine theta is equal to 1, when is sine theta equal to 1?
isn't it negative 1, sir?
Negative 1, yeah. When would sine theta be equal to negative 1? First of all, when is sine negative? Which quadrants? Third and fourth, so it's somewhere in the third or the fourth quadrant. What? It's a special angle. Sine is opposite over hypotenuse. If sine is equal to 1, it means opposite is equal to hypotenuse, because when these two values are equal, they cancel and give me 1, isn't it? When is your opposite equal to your hypotenuse? When is your opposite and your hypotenuse the same length? Usually the opposite is always smaller than the hypotenuse, because it's like putting a ladder against the wall. The ladder is the hypotenuse. The height that you reach on the wall is the opposite. Do you see what I'm saying? So we've got our ladder against a wall. So the closer I put this ladder to the wall, there's theta, that's my angle. The closer I put this angle, this ladder to the wall, the higher I reach, but I can never have my opposite, I can never reach higher than the ladder actually is. Make sense? Unless the highest I can get is the ladder's length itself. What would be the angle that the ladder makes with the floor? Fine. It's vertically upwards. That is for 90 degrees. So when is sine equal to 1? At 90 degrees. But 90 degrees is the first two quadrants. So which angle is it going to be? So look here. At 90 degrees, my opposite and my hypotenuse is the same length. But 90 degrees is in the first two quadrants. Sine is positive. I want -1, so it must be -90 degrees.
Oh, negative. So it actually
Because then your opposite is also equal to your hypotenuse. Okay, so for which values is it undefined? For theta equal to 90 degrees. And every time it reaches 90 degrees again. So plus 360 degrees times k. So this just means where k is an element of z. That just means that I'm adding a rotation every time, or subtracting a rotation, doesn't matter. So the next time would be 360 plus 90, 450. Or the previous one would have been 316. Sorry, that must be a negative. Sorry. So 360 minus 90 would be 270. So the first time it occurs is at 270. The next time, and we know that this is 270. The next time it occurs is 270 plus 360. Okay. Cool. That's some good introduction for the next thing that you have to be able to do. So we said, know your identities. Second thing, be able to convert a ratio into a triangle, and then use reduction formulas to simplify expressions that you have to use your triangle to solve. The next thing is you have to simplify expressions using your reduction formula and identities, or you have to prove identities using your reduction formula and identities, and usually algebra as well. Guys, if you don't know how to simplify a fraction, you are doomed to only get maximum 60% for trig.